Okay, here we are at happy number medium for the fast and slow pointer pattern of Grokking the coding interview. Our problem statement today is any number will be called a happy number if after repeatedly replacing it with a number equal to the sum of all squares of all its digits leads us to number 1. All their not happy numbers will never reach 1. Instead, they will be stuck in a cycle of numbers which does not include 1. Okay. Basically, what this means is we have 23, which has the digits 2 and 3. Boom, boom. 2, 3. So we square them, which gives us 13. Then we take 13, and we say it has the digits 1 and 3, 10, and we end up at 1. So that's a happy number. And this actually is similar to a linked list, right? This is either going to repeat forever, which means it's going to have some cycle to it, or it'll reach an endpoint, right? So on a linked list, the endpoint is when the next node is null. On this example, I believe the end is when we reach 1. So the problem with this is that potentially the cycle, this thing doesn't, like the pattern is so arbitrary that our fast and slow pointer would like never meet back up again. So I'm going to trust that that's not going to happen. And I'm just going to solve it anyway, assuming it won't. So what do we have? I got to get the digits off here somehow. So we'll say let how are we going to do this? Digits is equal to maybe there's a function for this that I don't know about. Frig. Let's just see if they have like... Oh, of course, of course. Digit is num divided by 10. Oh, but where did they get the initial value of num? Bum, 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 bum. So there's this num is equal to math dot floor num divided by 10. Yeah. So currently we get 13 and 5. So these are the first sums of both of these console checks, console logs. Yeah. So the way this works, number, we get a number, 23, and we take the number and we mod it by 10. What does that mean? I'll show you. It means we get this value. How does that work? Well, you can kind of think about it like subtracting 10s off. So, you know, we keep subtracting 10s until there are no more 10s left to subtract and we're left with 3. So, that gives us that. Then we divide our number by 10. So 23 divided by 10. Let's just pull that up on the calc. Is 2.3. And we floor it, which basically just moves the left digit over. And that's how we, if we have this, we peel off this value and then move it left basically. So keep peeling off values until we run out of values to peel off. Then our number is not greater than 0, and so it's over. This loop ends. That makes sense. We continue to add the sum. Okay, so this sum is 0, and we also, what do we need to do? We need to keep repeating this. Yeah, so let's just put this in another function like they did. Okay. So we're gonna get 13. And then we want to get 10, then we want to get 1. So 13 leads us back. So we want to advance 2 of these at a time. So we say let fast equal num, let slow equal num, and then while step 13 leads us back to step 5 as the number becomes equal to 89. This means that we can never reach 1, therefore 12 is not a happy number. Yep. But what does this mean more specifically? It means we need to either 1. What are we returning? True or false? Okay. So we'll use our while 1 loop again, because that's hilarious. And we shall do this. Fast equals get sum fast and we'll do that twice. And slow is equal to get sum slow. Now, if fast equals slow, I don't know if these numbers are going to be unique all the time. But let's operate under the assumption that it's the same as the previous problem. So if fast ever equals slow, we'll return false. And if fast is equal to 1, we'll return true. And fast will always reach 1 before slow will. So we got a true and a false, everybody. True, false. Woohoo! Process. We can use fast and slow pointers. Oops. Find a cycle among a set of elements. Therefore, each number will definitely have a cycle. I think the way this function works with the squaring, it kind of like always gives the numbers like a unique value, whatever, QED, more mathematical induction perhaps. So let's see what they do. Find some square, yep. I stole that. Yep. And they do this. Slow is num, fast is num, yep. And they call the same function twice, exactly like I did. If the cycle breaks, ooh, they did while true as well. Let's freaking go, buddy. If slow is fast, return false, and I should use triple equals if I wanted to be super cool. We found the cycle break. Return slow equal 1. That's, I did the same thing. It's a different syntax. I don't know. To me, this is more readable, but up to you. And what's also up to you is whether or not you'll join me in the next episode of Dragon Ball Z.